My name is Nakaungu Teddy, a computer science student here at Macquarie University, and I'm from Group 4, that is for computer graphics. And I'm going to be presenting on advanced computer graphics education content authoring for Refugee Accelerated Competence-Based Curriculum. And I'm also going to talk about some of the papers that I was able to review. So first of all, this work looks at how new AI technologies, especially large vision and multimodal models, can help us generate education, graphics, animations, and also stories that are tailored to the needs of refugee learners in Uganda. So when we were to look at the overview, traditionally, computer graphics education content has been created manually. That is when using tools like Blender, Unity. But then we realized that this whole process, first of all, it is slow, it is technical and not at all scalable for large numbers of learners. And then the other thing is that today we've seen a shift. That is, we've seen large vision models that can generate 3D scenes, animated characters, and even produce entire visual stories like automatically. But then there is a challenge. The challenge is that if the generated content is not culturally relevant or aligned to Uganda's competence-based curriculum, then that means that refugee learners may not benefit fully. So that is why I propose using retrieval augmented generation to ground the AI output in local context curriculum goals and also have a feel of the real refugee experience. And then on the other side, when reflecting on that shift and then the previous lecture, I realized that the focus is no longer just on designing models manually with the tools I've talked about, that is Unity and Blender, but rather it's about fine-tuning existing models, designing a pipeline, and also ensuring cultural and educational alignment. So this means that our role is somehow shifting from asset creators and into pipeline designers. And then we also put in consideration real world impact, which also matters. This means that the content that we are trying to generate must be multilingual. It should be lightweight for low bandwidth areas like the refugee communities, and it should also be culturally adapted. So I'm going to go through some of the papers that I was able to review. And the first paper I reviewed was about the mini GPT-4 model. For this paper, it replicates the GPT-4 vision language abilities, but with a much smaller architecture. So the problem it basically addresses is that existing large models require massive data sets, and in most cases, they hallucinate image captions, meaning they struggle with spatial reasoning of the images. And that image in there is an example of it generating the captions for the image. And then when it comes to the computational architecture, its architecture is very simple, but it is effective. It uses a vision transformer to extract image features and then project them into a language space. After which, it connects to a Vicuna large language model. So that diagram illustrates the architecture, the flow, how the architecture flows for the model to work. So basically, the mini GPT proves that we can build lightweight systems that still achieve strong performance. And then for our case, for our project, it is important because refugee learning solutions must run on even limited resources. But then on the other side, looking on its weakness, for example, hallucinations and also limited spatial reasoning, it means that we cannot use this mini GPT-4 model unless we first fine-tune it, meaning it's not perfect for educational use without further fine-tuning. So basically, that's with the mini GPT. And then for the second paper, which is about the Quen 2.5 VL model. For this one, it's first of all from Alibaba, and unlike the mini GPT-4 for it, it's a very powerful vision language model that can handle not just text and also images, but it also handles documents, graphical user interfaces, and even videos. So its key innovations are dynamic resolution processing, temporal grounding, and also video understanding and window attention for better efficiency. So for it comes in different sizes. That is from 3 billion parameters to a very large 72 billion parameter model. So that is basically the size. The sizes range from that. So, and then that image shows how the flow of the architecture looks like. And then the model is particularly relevant because it's practical for tasks like document analysis, optical character recognition, summarizations, and even robotic graphical user interface control. So that means that for education, like in our case, like it can analyze documents, summarize long videos, and this could be very powerful for creating and delivering refugee education materials. So basically that is it with the Queen 3.5 VL model. And then I also reviewed a third paper, which was about the PHI 3.5 vision. For this one, it's from Microsoft, and it is a smaller, efficient model with just 4.2 billion parameters, but it still competes strongly with much larger models. Then this one particularly focuses on three main areas. One, it focuses on single image tasks like the visual question answering. It also focuses on multi-image reasoning like art, all forensic analysis. And then it also focuses on video tasks like temporal reasoning across frames. So for it, its architecture is trained with supervised fine-tuning and also direct performance optimization for safety. And that is important, like for our case, because we need models that won't generate harmful or inappropriate content for children, the refugee children. Then in the context of refugee education, this model is useful because it balances efficiency with performance, making it more deployable in real-world environments with low resources, like the refugee communities. Then I went ahead and looked at another paper. And for this paper, it was about the M-plug all. And for this fourth paper, for it introduces the M-plug all model, and which takes another modular approach to multimodal AI. The problem it solves is that most large language models, they are strong in text, but they are weak in processing visuals. And its architecture adds a visual knowledge module, a visual knowledge module and a vision abstractor, and then aligns them with the language model in two stages. Like we can see it in the architecture diagram on the slide. So basically what's powerful about this model is that it can generate multimodal content without compromising the strength of text generation, without like compromising how text is generated. And for our case, with the computer graphics refugee CBC, this modular design is promising because it can be scaled or adapted depending on the task. For example, if it to generate educational stories that combine images and texts like seamlessly, then this model would be a great option. And then I went ahead to look on a fifth paper, which is about the video LLAMM model. So for this final paper, unlike others, for it, it specifically focuses on video understanding, and also combining both visuals and audio inputs. Sorry. So the challenge it tackles basically is that most models either look at static images or only audio, but they cannot capture temporal dynamics. That is how, that is the way things change, like across time when a video is playing. So for this model, it uses two branches. One, it uses a vision language branch, which is for video frames. And then it also uses an audio branch for speech, all sounds. And then, so using both those branches, they are aligned with the language model to allow audio-visual reasoning accordingly. So the diagram shows the architecture, its architecture or workflow of the video LLM model. So this model is specifically relevant for us because our goal is to create educational videos. And by combining audio and visuals, like this model directly connects to our use case of generating interactive lessons and storytelling for learners. So after reviewing all those models, it brings me to my proposed architecture. So now, building on the insights of the papers reviewed, this is the proposed architecture for the Refugee Education Content O3. And now let me explain it in detail. So first of all, the goal is to create a pipeline that can automatically generate curriculum-aligned and culturally relevant, even lightweight educational stories for the refugee learners. So this architecture basically has three main parts. One, it has the input and retrieval part. It has a multimodal processing part, and it also has the content generation and delivery part. So for the inputs and retrieval part, which is the first part, inputs include video frames, we have audio tracks, and it could also be text prompts from the user. In this case, those could be the teachers. But then to make sure that the content is not generic, we also integrate retrieval augmented generation module to make sure that content is non-generic. So this module, it modules a database of Uganda's, it incorporates a database of Uganda's competence-based curriculum documents, teachers' guides, and also things like local culture materials. So during the generation, the system retrieves the most relevant passages and then fill them to the model, ensuring that every story or lesson stays aligned with the CBC of Uganda and its objectives, and also the local context, so that it benefits the refugees particularly. So then for the multimodal processing, that's the second part. For it, by this time, we process the inputs using specialized encoders. One, we use a vision encoder, like the vision technology, or the BLIP, two, that handles images and video frames. And then we also use an audio encoder, like the image blind, that one processes narrations or speeches. And then we also have the text encoder, which handles user inputs. So that's so that during processing, we then synchronize the streams. These streams, which could be text, which could be audio, or could be video. So we synchronize these streams, and when synchronizing them, we use Q-formers, which is one for, we use two Q-formers, one for the videos and one for the audios. So these modules align temporal and multimodal features so that the model understands how the visuals, the sounds, and also the text connect across time. Like when the texts come in, to which visuals and what sound comes out at that particular time. And then at this point, these fused embeddings are then projected into a shared space, which is the multimodal alignment layer, which is a projection layer. So these embeddings are then projected into that shared space, and they are passed to a large language model. For example, we could take an example of the LLAMA, the 2.5 VL, all the vicuna. And then this LLM, all the model, the large language vision model, is responsible for the reasoning, composing story scripts, and also generating like scene graphs. So that brings me to the final part, which is the third part, and it's the content generation and delivery part. So at this point, the LLM outputs are then sent to a text-to-animation module, which then converts them to a graph, to graph scenes or 3D animations, all interactive lessons. So in this case, we could use the tools Unity and Blender that can render these lessons into lightweight formats, such as the GLB, the LOTO, the SCOM. And these formats are then optimized for the offline first environment, so that the tool can be used offline, so that learners in refugee settlements can use this even without a reliable internet. So to add on all that, a teacher-facing interface is included so that educators can validate the cultural relevance and also adjust languages and also co-create content. So this makes the system both scalable and inclusive, because we have very many people, like the teachers, and engaging in it. So when it comes to the part of novelty, from each paper that I reviewed, for this architecture, the novelty comes from how it integrates unique ideas from recent vision language models into one pipeline. So from the mini GPT-4, we borrow the lightweight projection approach. So this lets us run small models that still deliver strong performance. And this makes it also practical for low resource devices, like the ones used in some of the refugee communities. And then from the Queen 2.5 VL model paper, we adopt the dynamic resolution and windowed attention. These two techniques make it possible to process long videos and also document documents. It helps us to do all that efficiently, which is important for creating educational video lessons, for our case. Then from the PHI 3.5 vision, from that paper, we integrate efficiency and safety post-training, because we want to ensure that our system produces child-safe content that remain deployable even in low-resource settings, all communities, like the refugee communities. So that we can produce content that is not harmful to the students, the refugee learners. Then from the MPlug all, we use modular vision abstraction. So instead of processing raw pixels only, we extract high-level visual concepts, such as the market scenes, maybe washing hands, things like that, which the large language model then uses to build the curriculum-aligned stories. So then we also have the vision LLM AMM model, which we read from its paper. From that one, we incorporate an audio branch, and this allows us to synchronize narrations in multiple local languages. Remember, these refugee learners, they come from different countries, so they have different languages. So this helps us synchronize narration in multiple local languages and also enable audio-visual reasoning for story-based lessons, like we intend for our project. So about the originality of the project, it's not reinventing graphics like from scratch, but then it is about fine-tuning and combining these advanced components like into a lightweight, teacher-friendly pipeline that can be used in low-resource areas or environments. And then by doing this, we directly address the missing pieces, wall gaps in the literature, which are some of which are offline deployments, curriculum grounding, and cultural adaptation, all adaptation, and then resource efficiency. And then this helps us ensure that refugee learners receive content that is not only engaging and interactive, but it is also meaningful and very accessible to them. This is all I had. Thank you.